Every time there's a thunderstorm, we see the sky suddenly light up. And for a split second, it feels like there must be a huge amount of energy in there. So if lightning is that powerful, and Earth gets so much lightning every day, what if we collected all of it? Could we use it to power humanity? At first, this idea sounds pretty reasonable. No coal mining, no burning gas, no waiting for the sun to rise, just catch the electricity falling out of the sky, and humanity gets free energy. But before we start building lightning power plants, let's do the math. On average, Earth gets about 4 million lightning flashes every day. In other words, somewhere on Earth, lightning strikes about 40 to 50 times every second. That is already a ridiculous amount of lightning. So how much energy is in one lightning bolt? The answer varies a lot. Not all lightning is the same, but for a rough estimate, let's use a common number. One lightning bolt has about 1 billion joules of energy. In more familiar units, that is about 278 kilowatt hours. And 278 kilowatt hours is not nothing. For an ordinary household, that might be enough electricity for several days. So if we only look at one lightning bolt, it really does feel like a little electricity coupon falling from the sky. Now let's scale that up to the whole planet. 4 million lightning flashes per day. About 278 kilowatt hours each, multiply them together, and you get about 1.1 billion kilowatt hours per day. 1.1 billion kilowatt hours sounds enormous. If that number appeared on your electricity bill, your first question might be whether you accidentally bought a city. But here's the problem. Humanity uses a lot of electricity. China uses about 27 billion kilowatt hours per day. The United States uses about 11.5 billion kilowatt hours per day. India uses about 4.8 billion kilowatt hours per day. And all of humanity together uses more than 80 billion kilowatt hours per day. So all the lightning on Earth in one day would power China for about 1 hour. It would power the United States for a little over 2 hours. It would power India for about 5 to 6 hours. And if we shared it across all of humanity, it would last about 20 minutes. That means even if we really collected every lightning bolt on Earth for an entire day, it still would not launch humanity into the lightning energy era. At best, it would keep the world running for a short while. The lights turn on, the air conditioners start, phones begin charging, and about 20 minutes later, the power is gone. At that moment, you realize something important. Lightning is powerful, but modern civilization is even more powerful. The electricity we use every day is not just for lights and phones. Factories, subways, hospitals, ports, data centers, air conditioners, electric furnaces, and charging stations are all constantly eating electricity. Lightning looks like a sudden explosion in the sky, but the human power grid is a giant machine that runs all day and all night, and it gets worse. Everything we just calculated depends on one very unrealistic assumption, that we can collect every single lightning bolt on Earth perfectly, with no waste at all. In reality, that is basically impossible. First, lightning is not controllable. With solar power, you at least know when the sun is going to rise. With wind power, you can forecast where the wind will be. But lightning does not send you a schedule. It does not say, I will strike at 3:17 p.m. right over here. It might strike a mountain, it might strike the ocean, it might hit a tree in a forest, or it might never touch the ground at all, because a lot of lightning happens inside clouds, or between clouds. So collecting lightning is not like building a solar farm, where you just choose a sunny place and install panels. First, you have to solve a much stranger problem. Will the lightning even come to you? The second problem is that lightning arrives too suddenly. Normal power systems want stable, controllable current, but lightning releases a huge amount of energy in a tiny fraction of a second. The voltage can reach tens of millions, or even hundreds of millions of volts. The current can reach tens of thousands of amps. This is not like slowly charging a battery. It is more like taking a massive electric punch and smashing it into your equipment instantly. And if the equipment cannot handle it, it will not politely say, charging failed. It will break or explode. So if you really wanted to collect lightning, you would need much more than a lightning rod. You would need a guiding system that can survive high voltage impacts. You would need a buffer system that can absorb energy extremely fast. You would need conversion equipment to bring the voltage down to a safe level. And you would need a huge storage system to hold the electricity afterward. That whole system would be extremely expensive, and the energy it is waiting for would appear randomly. Even if we were very optimistic and somehow built this system, its efficiency would never be 100%. If we could collect only 10% of the energy, then one day of global lightning would power humanity for about 2 minutes. If we could collect only 1%, it might last just a few seconds. In other words, you could spend a massive amount of money building a global lightning collection network, only to make all of humanity's appliances briefly turn on. And that is why, in real life, when we deal with lightning, our main goal is not to collect it, it is to avoid it. The purpose of a lightning rod is not to generate electricity. It is to protect buildings and people. It is not saying to the sky, thank you for the free power. It is saying, please go safely this way and don't destroy the house. So lightning does have energy. That is not the problem. The problem is that its energy is too scattered, too sudden, and too hard to control. It is not like solar or wind power, which can be planned and used with some stability. Lightning is more like a random high-voltage shock thrown down from the sky. You can try to catch it, but catching it may be harder than using it for power. So if we collected all the lightning on Earth, how long could it power humanity? In theory, about 20 minutes. In reality, because of collection efficiency, equipment losses, and cost, probably far less than that. Lightning is strong. But it is not the answer to humanity's energy problem. It is more like a reminder. A force that lights up the sky for a moment may not be enough to carry us through a long night.